Coroneos 100 integrals, question 13. How do we integrate this one? It's a fraction again. However, the numerator, the power of the numerator is smaller than the power of the denominator. So we can think about using the logarithm. All right. So try to differentiate what's the denominator. If we differentiate the denominator, the answer is equal to 2x plus 2. But that's not what we want, right? We want 2x plus 2 here. And that's 2x minus 1. So what do? Change it. You want 2x plus 2? Well, change that to 2x plus 2. We'll use algebra manipulations. We can change that into 2x plus 2. Now the problem is, once you change that into 2x plus 2, you basically change the question. So what you need to do is change this one back. How about minus 3 here? 2 minus 3 is equal to negative 1, so basically these two expressions are exactly the same. Alright, but I can group them, so I can change them into two fractions. And the first fraction will be 2x plus 2 over x squared plus 2x plus 3 minus 3 over x squared plus 2x plus 3 dx. So once you finish up to here, then the work is really easy to do, because as you can see, that is just a logarithm integration. But what about this one? How do we integrate that part? All right. Let me just write it here. The first one is just a logarithm integration. It's really simple. I'm just going to rewrite this one again. Now the second one. Looks like very similar to something that you can do completing the square. All right, because that looks really, really similar to the inverse tangent integration. So using the completing the square methods, plus 1 and you plus 2 dx. So basically you separate that 3 into 1 and 2. I still copy down everything. I don't want to integrate, okay, right now. Here that gives you x minus plus 1 squared plus 2 dx. Now clearly this becomes the inverse trigonometry and an inverse tangent formula. All right, when you integrate it. Now I can integrate both one. Right, so that gives you ln absolute value x squared plus 2x plus 3, because the derivative of the denominator is equal to the numerator. So I can integrate like this. The next one is just the formula. That's the fx. If you differentiate fx, it's just equal to 1. So it becomes 3 over, we need to change that into the power. But right now this is equal to 2. So what we can do is we can do square root of 2 and square. So that becomes 2. So it's 3 over square root of 2 tangent inverse x plus 1 over square root of 2 plus it. And that becomes the answer for that question. Alright, very special, where you do need to look at the power difference between the numerator and the denominator and try to differentiate what's the denominator and use the algebra manipulation to change the fraction slightly so you can integrate using both logarithm and inverse tangent. Okay, thank you.